Welcome back to Health Savvy channel. Today, we're going to discuss a fascinating topic that has been on our mind lately. Why isn't seawater converted into drinking water? Now, you might be thinking, well, it's because it's too salty, right? But there's actually a bit more to it than that. You see, seawater is a complex mixture of minerals, salts, and other substances, and it's not just the salt content that makes it unsuitable for drinking. So, instead of asking why we don't convert seawater into drinking water, let's explore the fascinating world of water, desalination, and the challenges we face in making seawater drinkable. Here we dive in a little deeper into this intriguing topic. Seawater is abundant, covering over 70% of the Earth's surface and providing a potential solution for water scarcity. However, it cannot be directly consumed due to its high salinity and presence of impurities. Converting seawater into drinking water involves a process called desalination. This process is complex, expensive, and requires significant amounts of energy, which limits its widespread adoption. The main techniques for desalination include thermal distillation and reverse osmosis. In thermal distillation, seawater is heated until it evaporates, leaving the salt and other impurities behind. The vapor is then condensed into fresh water. While effective, this process requires large amounts of energy, making it costly. In reverse osmosis, water is forced through a semi-permeable membrane that filters out the salts and impurities. While more energy efficient than thermal distillation, this method also requires expensive equipment and regular maintenance. Another challenge with desalination is the environmental impact the process produces. A concentrated byproduct called brine, which is a mixture of salt and other chemicals. If not properly managed, this brine can harm marine ecosystems by increasing salinity levels in the surrounding water. Desalination plants also consume a lot of energy, much of which comes from non-renewable sources, contributing to carbon emissions and climate change. Despite these challenges, advances in technology are making desalination more feasible. Researchers are developing innovative membranes that require less energy and are more efficient. Solar desalination, which uses renewable energy from the sun, is being explored as a sustainable alternative. Additionally, some countries like Israel and Saudi Arabia have invested heavily in desalination, making it a key part of their water supply strategies. Water scarcity is a global issue, and desalination offers a potential solution. While the process has its limitations and environmental concerns, it represents a step towards addressing the challenges of providing clean drinking water to regions affected by droughts and water shortages. As technology continues to evolve, the hope is that desalination will become more efficient, affordable, and environmentally friendly, making it a viable option for sustainable water management. Thank you for joining us today, and don't forget to like, share, and subscribe for more engaging content. Until next time, stay hydrated and stay healthy, stay happy, and have a great day.